Anybody know? Wait, do you think you know?
I can't put my finger on it.
Not even. It's Sherlock. If you watch the BBC TV show like Sherlock,
My dad watches it a lot.
how do you hear it? I love that in this video. So that guy that I'm watching is just called Heavy Piano, because it's all just piano music. I actually reached out to him one year and I was like, dude, I was listening to your music all the time at school. And he sent me a bunch of stickers. So if I find them and you want some stickers, I have some Heavy Piano at YouTube stickers. But I thought it was very funny in that video. He's playing so intensely. The camera's on the piano and it's shaking as he plays. So it's really funny. All right, so today. That's pretty tough to do. All right, we all need to focus up. If you were on the band trip and didn't get a 431 and still don't have one, please raise your hand. I will bring you one now. And anybody still need a worksheet from yesterday? Okay. Tomorrow's should be back here by this afternoon. Copies show up at like 2 o'clock. So maybe before that, but if you are in extensions wanting the next homework, it is canary, so it'll be a yellow shade. I'm just going to work my way down the list to keep life easy. So our first one was white, the next one will be canary, the next one I think is cherry. I know the first one is white. So this chapter, the first one works white, and then it will make sense. All right. Anybody want to read? And we all need to follow along on the board and read along because this is why you were probably confused on your homework. Toby, hit us with the first paragraph.
Mathematics can be used to describe patterns in the world. Scientists use math to describe various aspects of life, including how cells multiply, how objects move through space, and how chemicals react. Often when scientists describe these patterns, they need to describe something that changes or varies. Scientists can call the quantities that change variables in their system using letters and symbols.
Wonderful. Go ahead and do the next one.
In this course, you will spend time learning about variables, what they can represent, and how they serve different purposes. To start, you will use variables to describe dimensions and areas of different shapes. You will begin to organize the descriptions into algebraic expressions. As a group of teammates, use these questions to help focus your team's discussion.
Everybody get out this and this.
Combining like terms.
Yeah, you could just say like terms, but combining like terms. Yes, the blue ones, the like turquoise. So these are what we are going to start to use to represent variables. And as Toby just read for us, a variable is something that can change. So on your paper right now, just trace these. And actually, you might as well go ahead and pull out one of the itty-bitty squares and trace one of those too. Itty-bitty squares. So to make my life easy, there's my traced objects. Now, why do you think one side is a nice color and the other side is red? Araya? Yeah, we need to have positive and opposite values able to be represented. Now, when we start talking about variables, yes, Eric?
You don't need to trace these in any specific way, right?
No, just square, bigger square, rectangle. Yeah, you're tracing. I said that. He's tracing. Yeah, the square, the bigger square. And so the little square, I think we worked with algebra tiles a little bit this year. Anyone remember what the little square is? 1. It is 1. So please, on the edges of that little square, put a 1 and a 1. And inside of it, put a 1. Because a 1 by a 1 makes a 1.
That's 1 too many.
What is the most common variable we use? X. So that's where we start. We are going to name this tile X. Now, why that tile is X is because this dimension is 1, and we don't know what that dimension is. Pull out the 5 tile, which is the weird connected, it literally is like 5 like welded together in a way. Pull out the 5 tile. Try to line that up with your X.
Hey, wait a minute. We had these in this stripes class last year. Yes, we did.
Yes, I know some of you have probably seen these, some of you probably haven't. So if we try to line that up, is it a perfect 4? Is it a perfect 3? Is it a perfect 3.5? No. So like this is uncountable. Now actually, Logan will be really upset if I can't find it. Actually, this X tile, look up at the board. This X tile can stretch. So you need to, in your head, imagine we don't actually, this is not like 3.7 or any, it is some amount that we can't count. We don't know how long it is. So major thanks to Logan for making my stretchable X for me. But label the edge of that X, right? X by 1, and you can label the other parts of it if you want. Now, if you work to line up tiles, what else lines up with our X that we just labeled? What else lines up with our X? Bella?
It's the same. Oh, it's like the size of these.
You have both sides of this square, right? So label both of those sides X. And if it's X by X, it's X squared. Please make sure that you do not let yourself think that this is X. The rectangle is X because it's X by 1. The square is X squared. And when we talk about squaring a number, that's why. That's why it's called square, because if you make it dimensionally, that number squared, if you square it off, like what's 5 squared? If this was 5 by 5, 25. So if we know what X is, then we can figure out what X squared is. But if we don't know what X is, then it is just X squared. And we wait. Meredith, you okay?
Yeah, I dropped my pencil
And then dropped yourself.
yeah.
Any questions on those tiles? Now, we will go further because, you know, what? You're literally like missing a tile from your bag. So now hold on. You should, unless your bag is sad like Zach and Nick's, you should also have these tiles. Now hold up. You do not have to trace these. But if we say that those tiles are the next tiles we work with, take a moment, play with it out at your desk, figure out what those tiles would be called. Take a moment. Or do you have a question?
I already know the answer.
I already know. No. Well, I have 2 X's up there. Yeah. But this purple, that purple, and that green. Why is this green a different color than everything? Like, that's what we're wondering.
Make a massive face.
Oh, I took most of those out. And if you have a cheat sheet, ignore it. Okay, Araya.
Yay.
What is this tile called?
Why?
Because I asked you.
No.
Oh.
Why?
It's y by 1, right? It's 1 dimension. The short side is 1. I said do not jump them out. You have a mess to clean up. And just by the way, these are like an endangered species. every year when I teach this, one tiles are getting sucked up by the vacuum. So please, if it falls off your desk, get it immediately. This carpet, this is like invisible on this carpet. It's like the same color.
Oh, yeah.
So please, if something falls off your desk, get it immediately. So that's why. But wait, Aurea, what's this?
Y squared.
Y squared, because it's y by y. And then the green tile, anybody who knows it, xy. Careful, it's not. This dimension lines up with x. It's the same. And this dimension lines up with y. It's the same. So that tile is actually an area of x times y. So, dudes and dudettes. Dudes and dudettes, I'm losing you because I gave you things that are fun. I know they're fun, but bring it back. You don't need to know about the y's yet, but you will. Okay, we're headed there. On your desk, let's talk about algebraic expressions, right? What is the difference between an expression? Actually, for now, put them all back in your bag. Let's take a because the next slide is get out specifically these tiles. So for right now, put them all back real quick. Yeah. What's the difference between an expression and equation? Savannah?
The equation gives you the amount that it equals, the sum, whatever you want to call it.
Yeah.
The answer. And then an expression doesn't give you the answer.
Yeah, an expression does not give you the answer. An expression doesn't have the equal sign, right? So, an equation actually has two expressions. It's got one on one side of the equals and one on the other side of the equals. Each of those is an expression. And actually, each of those expressions could have multiple expressions in it or multiple terms. Right, we talk about terms. So when we look at tiles, and don't get these out right now. We'll get out tiles in a moment. We group tiles just like we group like terms. So the same size of tile means that they are like terms. So I'm going to use a highlighter to do this. Right? How many x squareds do we have? Well, there's one there. How many others? Just one. Okay, well, I'll change my color then. I've got x's next. These and these. 6. Okay, and then my ones, there. 8. So when we write this out, we would say we have 1 x squared. And you don't have to put the 1, but for right now, please do it. Plus, you will in a second when we pull out the other tiles, 6x plus 8. We cannot put those values together because they're different sizes. Right, Toby? Yeah, didn't ask the question. You're really fascinated by what's happening on Nikki's desk. And she could be what's on your desk or up here. So, any questions on why we can't put those together or why we write this like this? Any questions at all? Yes.
Okay, so when you put all the shapes like next to each other, will it still be the same problem? Or would that change?
So it depends if you're asking area or perimeter.
Okay.
Right? So on your homework, 75 and 80 talk about area and perimeter. I think on the next homework that you can pick up later if you want, we investigate. If I move tiles around, I still have the same area, but my perimeter probably changes. Right? Like the amount of outside, probably whether I lay them all out really long or like push them all together and try to make it kind of square, the perimeter is going to change. So let's start looking at this. Pull out these tiles from A. So just group A as like a team.
Oh.
They're the x squares, so you tell me. You do not need to draw it, but we are going to write it on our paper as an expression. Once you have them out, write an expression on your paper for what you have. Write an expression for what you have. So I was waiting for somebody to ask the question, do we have to get these out to be able to write the expression? No. So that is a strategy. Sorry, I peeled off a label and it ripped. So now, I've heard a lot of people say this, so I'm going to go ahead and guess that it's right. I've heard a lot of people say 3x squared. Do we agree?
Yeah.
Okay, class. We'll just go class answers. You look like you were like pointing a gun. I think Savannah just wanted me to pick on her. How many x's, class? Anybody?
6. 5.
Ooh, hold on. Here's an x, 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 x. Careful, that's 6 x's. And then 5, 10, 15, 16, 17, 18. Now, up here, my tiles are gray, right? Yours are blue or red. So I was waiting for somebody to say, wait, are these blue or red, or what are they? Anything in CPM that is grayed in, filled in, is positive. Anything that's left empty is negative. It means you're lacking. You have a debt, a missing, a negative, whatever you want to say. So anything shaded in is positive. For B and C, I want you to write out the area and try to start thinking about perimeter. That's why we're coming back to it.
Okay.
So I'll give you probably 3 minutes, down to the 30 at least. Because they're put together, start thinking about perimeter. That's a good thing. It means some of last year's stuff at least.
I love algebra. I don't know why. I just do.
It's your brain is normally either algebra loving or geometry loving.
I love B.
Well, maybe they aren't fond of you either.
Yeah.
Oh yeah. Yeah. Area perimeter. I got a question. And it's going to Toby because his card's on top. Toby. Toby. Maybe. So Toby, if I ask you the length of this blue section just right there, what is that?
You could say that the X tile could equal like 1, let's say.
We don't know what it is. You can't just go making things up like that. So wait, back to yourself. You said it's an X tile. What's the length of an X tile? X. So that's X. And then this is 1. So the top is X plus the extra 1 right there. What is this dimension? Bella? X minus 1. Lily, what is that length? But is there anything else you could do with it to make it easier? That's not X minus 2. That is actually, Lily's right. Don't fall in the trap. All because it's split up like that doesn't change it. Nikki?
It's still X minus 1.
Right, yeah, Lily said that, but then I asked, is there anything else we could do to actually make our work easier? There?
I mean, you could try X divided by 2, but probably wrong.
And we're still missing a 1, right? Araya?
2x minus 2.
Ooh, it's not. Nikki, I'll come back to you because you look like you're going to jump out of your seat. Yeah.
You could do, this is something that I used to do all the time. You could do, if you wanted to, you could also include the little square and you could do x plus 2.
That is the missing section of the x, right? So this would fill in the x. So if I go to write out all of the green, eyes up here for just a second because this is going to help you like jump through it. We have x minus 1 plus 1, 2, 3, which ends up being x plus 2. If it works for your brain, I'm not telling you right, wrong, do it, not do it. Move the missing piece over, and then you've got an x. So over here with red, if I move that missing piece over, I've got an x. So then I've got x plus 2 on that left-hand side. Right? So the whole red here is x plus 1 plus 3 more. So really, stop. No.
Yes.
Go away. Really, it's x plus 2. So now knowing that, I just wanted to make sure we stopped and saw, like, that x isn't a whole x. We can make it a whole x, but we got to be careful. Let's walk around and collect every single part of this. We said this, I'm going to work it step by step, is x minus 1. Right? We said this is actually x plus 1. We said this was x minus 1 plus 3. Stop me if you get confused. The bottom, I'm grouping a little differently here. Ooh, x plus 2. I was just showing you options. I restarted now. I erased everything and I restarted. But if we simplify everything together, it should work. And then, I don't know what color, orange. I have another this and that. So another 2. Combine all your like terms. So, x, 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 x. How many x's in total? 4. Even though this wasn't a whole x, it doesn't matter. I used x in my expression. I have 4 x's in the expression. So 4 x's. How many constants? Well, I'm going to do positives, then do negatives. So 1, 4, 6, 7, 8, minus 1, 7, minus another 6. So that perimeter would reduce down to 4x plus 6. Does that make sense? Because all those different pieces, and they're color-coded up here, does that make sense?
Yeah.
What questions do we have?
Will we ever find out what is x?
X changes. It's a variable.
I know, but
It doesn't have one value.
in this situation, will we ever find out?
Nick, when you get your heart first broken, you'll know a lot more about X than you do now. So in C, try it on your own. Don't even talk to your partner. Try C on your own. What's the perimeter? And if you need to build it on your desk, build it on your desk. And then look at it from there. It was a horrible joke. When you have a free moment, when you're not doing that, read that.
Read what?
Trying to get these all opened up before Unplugged Club. Right? Do not snap it.
Our teacher told us
You.
not
What's that mean?
snap it.
That's
If we walk around the shape, we can gather everything up. Now, in the past, students have said, well, what if we just like push some things together to make it easier? That's going to change the perimeter. So we can't do that.
no.
No.
Wait, how do you find the little letter for the middle part?
Great question. So this segment right here,
Is x minus 3.
ooh, is x minus 3. If I only look at those two sections, guys, when we're doing work like this, start with the hardest part
Why?
because then it's over.
Why?
With any task that you have to accomplish, if you start with the hardest part, then it's over. So that part's x minus 3. But then, what is this?
X minus
X
Ooh.
minus 1.
Give me your eyes, because I need to make sure we all understand this. This length right here, I need a different color, is 2, right? Because each of those edges is a 1. So the green length up here is x minus 2. And so is this one, is an x minus 2. Does that make sense why those are x minus 2?
Yeah.
Then I might as well pick up the rest of the middle parts. So if I have 1, 2, 3, 4, 5, 6, 7. Now you could combine these differently, but we're breaking it up to try to make it like make sense to us. Then, and you can like make corners and stuff. What would this purple length be? X plus 1, right? So you could do the 1 separately, or you could say plus 1 plus x. I don't care how you write it out. Like, as long as you have all the pieces that you need. What's across the bottom here? X plus 2, or 1 plus x plus 1, or 2 plus x, or however you want to write it. So I'm going to keep adding things here. Plus 2 plus x. And then over here, another x and another 1. Get your like terms. And this is why it doesn't really matter how I wrote this stuff out kind of jumbled. Grab all of your x's. There's 1, 2, 3, 4, 5, 6. Right? So we have 6x. Get your constants. Negative 3. Oh, this is going to be annoying. Negative 5. Negative 7. Oh, wait. 0 now. 1, 3, 4. So, that. It's trying to make straight lines out of my not straight lines. 6x plus 4. Who's confused? What are you confused about? Well, don't raise your hand. What are you confused about? Is this making more sense than when you looked at 75 yesterday?
Yes,
Like when you first looked at your homework and like half of you were like, wait, hey, how do I? And I said, no, I won't answer questions. This is why. This is why I would not answer questions yesterday. So we've done more than the lesson needed me to up to this point, like because I wanted to be able to go and do at least one of your homework questions. These are easier than what we've been doing because I wanted to see if you guys could like do the hard stuff, right? What is this length?
I can't see
2x plus 1. Knowing that, figure out the perimeter of this shape really quick. It's an easier shape, right? One big long. So we know that's 2x plus 1. Write it down. Don't read. I'm hoping you don't read. Some of you are like, if you read, it's up here. 2x plus 1 for the one edge, right? Then the top would be a 1. And then the bottom is also a 1. And the other side is 2x plus 1. Right? 2x plus 1 on this side, 2x plus 1 on that side, an extra 1, an extra 1. When we put all those like terms together, 4x plus 4. Then, I hate that Toby left now. Then if somebody tells you what x is, like they say, hey, x is actually 5, then you can figure it out. Because you know 4x plus 4, well, I just plug in 5. If x is 5, what's your perimeter here? 24. That's why we use variables. Is this making a little bit of sense?
Yeah.
A little bit? Can you? Un poco. What's the perimeter of that shape? What is the perimeter? I'm sure you guys can all tell me the area. X squared plus 3x.
Yeah.
Right? Perimeter is the hard thing now. Yeah, you gotta write it down, please. Just so you know what you're doing. See if you got it good. I feel like there should be more X's for this one. I feel like there should be more. Think through it. So like, what's the left side? If you just write down sides at a time, how long is the left? So we're going to work through this a chunk at a time. Hands up, go down. If your hands up, go down. This edge is what? X plus 1. Because this is x and that's 1. This edge, another x. Then we've got 1, 1, 1. We've got 1 up here and we've got 1 up there too, so I might as well mark all those 1s. This edge, an x, and this other section up here, an x. So if we label each of the parts, it'll help us. Well, I don't have any negatives, right? I don't have any missing pieces, so how many x's total? 4. How many constants total? 6. So this is 4x plus 6. Does that make sense? What? I know. A lot of these I'm hoping you just look at the picture and don't read it. Because, you know, when there's lots of words up there, your brain's like, picture. But if you choose to read, then yeah, you can see it is 4x plus 6. But I just wanted to work through it. I don't cheat, I overteach. I overteach. That is my, like, my kind of mantra, my whatever. So, let's look at 75. Yeah. This was on, so get out last night's homework if you don't still have it out. Talk with the partners near you to make sure that you have the accurate area and perimeter for that shape. Notice that we're going to start low level and then get harder. Yeah. You're going to love it. Now you have to be honest and tell me which of those don't make sense.
The second power super
Alright, hopefully everyone has that back out now. What is the length across the top?
X plus 3.
Not just x.
Oh, X.
2x plus 3. It's not x squared, it's x and another x. Right, so the top is 2x plus 3. What's this edge? X. What's the bottom? 2x plus 3 also. And this edge is x. So all together, how many x's do we have? 6. So we get 6x. How many constants? 6. So our perimeter there is 6x plus 6. Now the area is the easier part of this. How many x squareds? 2. Yeah, because if x gets bigger, like that area space gets bigger. And how many x's? So 2x squared plus 3x. If you don't have the squared on the x, it is not correct. You got the last 4 minutes to, probably if you were here yesterday, you're probably close to done with that worksheet. So you got the last 4 minutes to work on that. Any other questions from the homework that you want me to talk about right now? 78. Oh, thank you, Toby. 78 is a great question that we need to start talking about right now because every year students struggle with the trapezoid. There are 2 ways to do this. Give me your attention. Because even if you did it the way I suggested in your homework, that's not like the way we're working towards. On your homework, I typed in, hint, if you like don't know the trapezoid formula, split the shape up, and to do that, you would just like split it into a triangle. But if you want the actual formula that we're heading towards, the area for a trapezoid, and you should write this down, but probably not inside your trapezoid, is base 1 plus base 2 divided by 2 times the height. I'm going to write that out like how we do that here. What that means is add up the 2 bases that you have, and by bases, we mean the flat sides, the sides that are parallel, like the bottom and the top. Divide that by 2, and then multiply it by the 10 height. That's the same exact thing that you'll get if you split the shape up. Because if I split this shape up, so I'm trying to get you out of here real fast. If I split this shape up, what's a 10 by 10? It's 100. And if this is 6 by 10, this is half of 60, so it's 30. Your area should be 130. And I think the guest teacher dismissed a couple moments early next door. We can probably push the wall open and then switch classes whenever you're ready. She was here. She's not now. Have a wonderful day, guys. Hey, spread word. Unplugged Game Club. Please let those kids go through line first.